In Unit 2, we looked at functions. One of the things that we looked at first was something called function notation. And that is, f of x is just another way of saying y equals. So this does mean y equals 1 over 2x. And so if I ask you to find f of 9, this is the input, which is the x value. So this is saying, all right, when x is 9, erase this right here. All right, so f of 9 means everywhere we see an x, we're going to plug in a 9. So here the x was right next to 2. We're going to plug in that 9 and solve. And so we get 1 over 18. So all this means is when you plug in a 9, you get 1 over 18 for your answer. You just plug it in. So that's function notation. Let's do another one. It says if g of x equals negative 2x minus 10, find x, the input, if the output is 16. So when we plug this in, now we have the answer. The output, 16, equals negative 2x minus 10. And then you can solve that for x. So if we solve it for x, we'll add 10 to each side. We get 26 equals negative 2x. We'll divide each side by negative 2. And we'll get x equals negative 13. So the input is negative 13 when the output is 16. So you have either the input or the output, and then you have to solve for the other value. We also took a look at some parent functions. We have y equals x squared. If I sketch that graph, it looks something like this. So this is our U-shaped graph. The vertex is at 0, 0. So that's called a quadratic, where x squared is the highest power. Then we had our square root function, which looks something like this. That's slowly increased. So there's the square root function. And the absolute value function, the vertex was at 0, 0, and it went up 1 over 1 in each direction. So here's our absolute value or V-shaped graph. So we took a look at those parent functions and how they shifted. So if you remember, if anything was inside the parentheses or the absolute value, this is left. Left was positive, and right was when it was negative. And then the plus k, this was up and down. Up was plus k, and down was minus k. And the same thing was for the absolute value function. The parentheses and absolute value, those are like the same thing. So there's your h value on the inside. Oh, and a right here, this was what we called the slope, how skinny or fat the line was. So it says, remember, in order to be a function for every x value, so this is the definition, there's only one y value, you can use the vertical line test to see if something is a function or not. So each of these are a function because for every x value, there's only one answer on the graph. So we can see that these are all functions. So the vertical line test helps you determine if something is a function or not. All right, this says find the equation of each graph, and also can you give the domain or range? Okay, so we know this is a square root function, y equals the square root of x, but it shifts to the left, and it goes left 1, 2, 3, 4, 5. So underneath the square root sign, you would have the plus 5. This one, okay, so remember the absolute value function was at 0, 0. So this one flips, and it shifts right 1. It goes up 3, and it's upside down, and the slope, to get from one point to the other, we go down 3 over 2. Okay, so let's put this all together and write the equation of the function. So we have y equals our slope, negative 3 over 2. We have the absolute value of x, and it's to the right 1, so that is minus 1. And it's up 3, so on the outside we'll put our plus 3. So that's putting it all together with up, down, left, and right, also your slope. So in class, we'll have time to work on the practice problems, which start right here on page 3 and go to page 4, and there'll be an answer key so you can check